Okay, and now it's time for our last, but not the least, talk of the day. It will be Mario Blazek, and the subject is Living with Open Source Responsibility. So let's hear it for Mario Blazek.
Okay, we can start. Welcome to my talk. This is the last talk of the day, so I'm hoping that you are not too tired. So stay with me for a while. So, open source. Today, if we see the PHP as a language with the open source background, you will see that everything basically around the language is based around the open source. But on the other hand, if you take a look, for example, at the Microsoft community, they are also open sourcing every single thing, from their .NET to frameworks, libraries. They're also moving into open source direction. Today, basically, there are even companies that base their businesses entirely around the open source. So we can see that the open source became ubiquitous. So it's ideal time to talk about it. Well, my name is Mario. I'm backend developer at Q Agency. It is a Croatian company based in Zagreb. We have branch offices all around the world. Usually what we do is web solutions, mobile apps, and API backends. I'm mostly engaged on the Gens. It is our startup project. It is a communication and feedback platform that serves as the internal social network for the companies. And it gained a lot of traction lately, especially during the COVID times. You may ask, why Q? Well, Q got the name from the James Bond movies. As you can remember, they have something called a Q branch. And Q branch built some cool some cool gadgets basically that saved Bond's life so many times. So we like to think about ourselves as the cool guys. I'm married. I have 2 beautiful sons. And personally, I believe in open source. And I try to promote open source as one of the organizers of the Zagreb meetups. And also, they call me a chief fire officer because I volunteer as the fireman at the local fire brigade. So, let's get started. So, the day 0. My story, how I got into the open source is this. So I should rephrase that. The story of how I created my first quality open source package is this. Back in the day, I was developing a solutions on top of the Easy platform, which is a content management system that is based on the Symfony. And I had a requirement to build some sort of form control that can be controlled from the back office, from the admin interface, basically. And the same solution existed, but it was based on the Easy platform version that was like 10 years old. And basically nobody wanted to use it, especially the juniors, because they did not understand the legacy. So I've decided, okay, I'm going to take my time. I'm going to develop a new solution on top of Symfony, and which worked rather well. But the mistake I did is that I left it in the project's code base. I didn't extract it. So after, on the next project, I had the same requirement. I need to build, again, some sort of the control. And I realized, okay, I've built that before. I can just copy and paste the code into my current project. It will work. But after some time, I again realized, okay, copy and pasting the code is stupid. It doesn't make sense. There must be a better solution, of course. So I was thinking about, okay, I should create some sort of reusable solution that can be installed on demand. And the first thing that popped into my mind was, okay, I should create an open source package. And first I was scared because, who is going to use the bundle I've built. Look at me. Today is rainy day and I have shorts. So especially, this was the picture that popped into my mind. There are all the senior developers looking at me, open source. Are you insane? But somehow I persisted and I created a solution and I published it because I believed that if that solution solved the problem for me, that it is going to, and basically it's still solving my problems, that is going to solve the problem for somebody else. So basically, the rest was history. And this is what I've learned as the maintainer of the open source package. So first of all, start small. Don't try to cover all cases that pop into your mind, because you will just start spinning around and you will never finish your project. You know that case, that you will never end up. Just try to find just a minimal MVP that will work. For example, in my case, the CMS had like a ton of field types, basically, that they had something called field types, and what I did, I covered only 2 cases. I covered like a simple text lines and simple text blocks, but they had like XML-based field types, highly complicated. But I didn't want to cover that because I didn't need that. My case was contact forms, and for contact forms, mostly it's enough to have a text line and text areas. So that was fine. So now, when you have defined your set of features, try to clean your code as much as possible before going outside. By outside, I mean by going to the GitHub, for example, to the external repositories. Try to follow the SOLID principles. I'm not going into that, what SOLID stands for, because you have a lot of great talks about it. Especially, I recommend checking talks by Stefan Pripsch and Tobias Schlitt, because their teaching style is awesome. So check those things out. Again, tests. There's so many talks about tests, so I'm not going to talk about them, because you should write tests, period. Do not try to cover, don't stream for the 100% code coverage, because this doesn't make sense. Try to cover the most critical parts with tests. And here are some libraries aligned that you can do testing with. For example, you have a PHP unit, which is like standard in the PHP world. You have a PHP spec, another great tool. If you are coming from JavaScript, then probably period and colon would look appealing to you, because they have like a functional way of writing tests, so they look very, very nice to you. They look very nice. Pest is a new kit on the block. I didn't use it, but it's gaining a lot of traction lately on Twitter, so I recommend checking it out. Next, what I have in line, there are tools that can help you maintain a high quality standards. Basically, you have tools like PHP CS Fixer or PHP Stand, for example, and those tools are meant to be used locally on your developer machine. So before going outside to the public repository, you run the static analysis or the CS Fixer, and you fix the code before going outside, and we'll see them more in detail. For example, CS Fixer is cool because you have like a configuration file where you can define your coding style. You run the CS Fixer, and it's going to fix the whole code base based on that coding standards, which is great because you can commit that configuration file, deploy it to your repository, so that all other contributors can use the same coding style as you, right? Another tool is called the PHP Stand. It is a static analysis tool. We know that PHP is not a compile language, which is kind of not true. It is basically, but we need a tool that can help us, like compile helps the statically typed languages. So we need a tool that can find the errors before we actually start executing the code. So PHP Stan can help you with that. It can find the wrong type hints, wrong return types, useless castings, for example, quite a lot. Another tool that we have at our disposal is Psalm. It's basically like counterpart to PHP Stan. It's another static analysis tool. It is developed by Vimeo, and I would say you don't have to use them both. Use either of one, because they are doing the same thing. They have their own peaks and perks, so play around a bit with them, find which one suits you the most. Another tool that's excellent is called a Reconstruction tool, or the rector for short. Basically, it's a tool that can help you automate the code upgrades. For example, if you are migrating from PHP Unit 4 to PHP Unit 8, for example, there is a lot of deprecations that occurred there. So you will need to go through the whole code base and updating, copy and pasting, replacing the code, and the rector can do everything for you automatically. The same goes with the upgrades to the PHP 7.1, 7.2. Just use the appropriate rector, and that's basically it. There are even more tools, like Infection PHP, which is de facto tool for mutation testing. It will try to break your tests, so you will see how effective your tests are. Another tool is PHP Insights. It's like a tool that will help you generate like a complete overview of you will receive the report of your code base. You will see how much cohesion do you have, how much complex is your code. Very nice tool. DepTrack is another great tool because DepTrack generates a dependency graphs. So you can see how much, for example, you are depending on the infrastructure layer, which is cool if you are doing a DDD style of development. You can see how much you are tightly coupled to your infrastructural code, which is not good. And we have a PHP mess detector, which is kind of tool that has a lot of resemblance with PHP Insights. So another tools, basically those previous tools, they were meant to be installed locally on your machine. These tools, they are provided like a third-party services, and you enable integration, for example, on GitHub, to use one of those or all of them with your GitHub repository. So, for example, tools like Travis, GitHub Actions. So let's check them more in detail. We have Travis CI. Basically, Travis CI was standard for all GitHub repositories because all the major players were using the Travis. But at some point, they have decided that they are going to shut down the free version of Travis, and they only allowed something like, I don't know, like 60 minutes of build time. So basically, everybody just ditched them away. The concept is very simple. You create a file called .travis.yaml, put all the configuration for the build inside. So here is an example configuration. Here we are running tests, for example, on the PHP version 7.2 and 7.3. And if we publish that on our GitHub repository, it will trigger the Travis build, and we will see something like this. We have, for example, two builds, 7.2, 7.3. 7.2 failed. Okay, let's see what's happening there. And we can see the error log in the console. Another tool that basically got in life when they ditched Travis was GitHub Actions. It is provided automatically by GitHub, and it basically does the same thing as Travis. Just create the configuration file, put it into the .github/workflows something.yaml directory, enable the integration, and that's it. And trigger the event by pushing the code to the repository. And you will see something like this. So for example, this is a configuration file for static analysis. We want to run PHP Stan Psalm, and we are running PHP Stan on tests. So we should have like a three times, we should see like a triple execution of our build. And if we go to the GitHub page, you have the Actions tab. On the Actions tab, we can see that we have a static analysis part. If you click on that, you can see, okay, we have 3 builds. And if we inspect it more in detail, all those steps that were defined in the configuration file were ran. And let's inspect the, for example, PHP stand part, and we can see the output of the PHP stand. Extraordinary useful tool. Another tool that I have in line is the Scrutinizer. Basically, Scrutinizer can do continuous integration part as the previous 2 tools, but what previous 2 tools cannot do is to generate like an overall code quality report that can be done with Scrutinizer. Basically, Scrutinizer is running some sort of PHP mess detector in the background and is displaying a nice reports for your code, and how it looks like this. We can see I've pushed commit onto the repository. It analyzes my classes. I have received some grades for every single method in the class. You can see the list of all classes in my repo. They have, for example, the info about coupling, cohesion, size, and everything else. So it's code quality metrics. Here is, for example, how they print out, how they suggest to update something in the code. For example, consider adding a comment. And basically, this is the overall score of my code. It can generate like an overall score. Another tool that I have in line is called a CodeCov. CodeCov.io is basically nothing but like pretty PHP units code coverage. So it can't generate code coverage by itself, and you need to send the code coverage to that tool. Usually you will run the Travis, generate the code coverage report, and send it to the CodeCov. And it looks like this. We can see code coverage for every single class. We can check even more in detail. We can see all those lines which are covered with tests. Basically everything is green. Again, the same thing as the HTML report of PHP unit, but it's a bit more fancy. And there are even some more tools like Code Climate, Circle CI, Bitbucket pipelines if you are tied to Bitbucket, because GitHub has a lot of integration with basically everything. If you're hosting your repos on Bitbucket, then your possibilities are a bit limited. The same goes with GitLab. They have their own CI. I don't think that Travis works with Bitbucket. Maybe they updated that recently, I'm not sure. Okay, so the next part is the documentation. Documentation is something that makes a software great. Basically, it makes the project, makes the overall package, improves the overall package quality. And you, as the author of the package, you should tell us, the developers, how we should use your code. I don't want to go into the source code every single time when I install the dependency and to try to figure out how it works. It's your job to provide quality documentation for your code. It is okay if I have to debug something to go to source code, or if I want to learn, but just to install it, no. So try to document like installation procedure, try to document extension points, code upgrades, stuff like that. And usually, if you put your documentation into Markdown files on the repository, it's basically perfectly fine. You can like organize them into the multiple Markdown files, or you can put the whole documentation into single Markdown file. It's perfectly fine. But I deeply suggest that you take a look at some of those documentation systems that can help you version the documentation, that can help you build the documentation, and that can even help you with hosting the documentation. And you can easily migrate from Markdown files to those tools because all those tools support Markdown syntax. So it's very easy. Personally, I'm a big fan of read the docs. So in my case, it looks like this. So you can see that basically all those links, content lists, they're all generated automatically. I just put my documentation, run the build, that's it. Read the docs is based on Python, so it takes a bit of time setting it up, but once you do it, you're okay. And I have included a blog post where I have documented the installation procedure and configuration for read the docs, so feel free to check it out. And basically, we are done with the documentation. So what's next? When we talk about open source, the next thing I suggest looking is licensing. Because I suggest that you choose a proper license. Because the folks that are going to use your code, your project will look more appealing to them than code without the license, especially to those who have to provide enterprise support, for example, like Symfony. If you don't have a proper license applied, Symfony will never install something for you. For example, like a few years ago, they created a repository for hosting their recipes for Flex, and they forced you to use I'm not sure which license was in question, but only the packages with, for example, the MIT license or something like that. You have like a big pile of licenses. The most important ones for me personally are the Apache license, the MIT, and the GPL in version 3. The MIT is like least restrictive, GPL in version 3 is very restrictive, and the Apache sits somewhere in the middle. And you have a website called Choose License that can guide you through the process of selecting a proper license. Definitely check it out. But on the other hand, if you basically don't care about your code, but you want to have some kind of license applied to your code, you have two options. You have an option to go with something called unlicensed something, and you have this one, VTFP license, or do the fuck you want to public license. So basically, you are allowing third parties to do whatever they want with your code. And I have included the link to this blog post because it's interesting, because Elastic Search Engine, as a project, it was released under the Apache license. And in 2015, they switched to something called Elastic license. Why? They switched because Amazon or the AWS, they started offering something called Amazon Elasticsearch Service. As you can see, they basically use their naming for their own portfolio, which is not very good. And you may ask yourself, okay, but the code is free on GitHub. It's published on GitHub, yes, but the naming is not. That's the difference. And now the big one. So versioning and releases, it's one crucial point in the open source. First, before releasing your first stable version, you should define something what developers call a public API. What is a public API? Public API is the part of the code that the other developers who are using your library, they will interact with. So for example, imagine you want to build like weather forecast client that fetches the weather forecast from Open Weather Map service. You will probably have like a ton of utility classes, helper classes, factories, whatever. And on the other hand, you would have something, you would have like a one service and a method that, for example, takes the city name as the argument and returns the weather forecast object back to you. So that is going to be your public API, that service and the method, because other developers will use that service, they will call that method, and they will expect results. They will expect the same results from version to version. And that is where semantic versioning, or the SEMver for short, kicks in. So for example, here is the stable version 1.0.0. Ignore the beta label for now. And this first number is called a major version. And major version must be increased every single time when you introduce a backward incompatible changes. So every time you break your code. So for example, in case of our Open Weather Map service, imagine that you realize that the method accepting the city name is not enough, and you want to have like geographical coordinates instead, because you will have a better coverage. And you change the method, you deploy that to the GitHub, you release it, and then what happened? What happens then? You will have a bunch of angry developers screaming at you on Twitter and opening tons of issues of GitHub because you broke their software. They installed your project into their code base, and now they have issues because their software doesn't work because of you. So don't do that. The second number is something called a minor version. Minor version needs to be increased every time you create a new feature, but new feature in backward compatible manner. So again, you need to stay backward compatible. Again, example, our Open Weather Map service, you introduce a new method that is accepting geographical coordinates. So now you will have two methods, the old one and the new. So the old one still works fine, perfectly, and you have a new one with the new functionality. Yay, and you will have happy developers. And the third number is something called a bug fix version, which you need to increase every time you provide a bug fix. Okay, so let's see the strategies that you can use to maintain the software in that way. There is the first one is something what I call a flat model. This is something I made up because this is how I maintained one repository. Because, for example, you have like a master or main branch, and at the point when you tag the first stable release, you have to create 1.x branch. This branch will serve you as your development branch for the version 1. And you add new commits, you add new features, and then you tag a new minor version. Then, for example, you have a bug, you introduce a bug fix, you tag a bug fix version, and so on. Basically, you're going into the straight direction. The problem with this approach is that you can't support previous versions, because you can't go back and, for example, introduce something into version 1.1. It will not work. But it doesn't matter, because if you have a simple project and you keep up with you watch your backward compatibility, this is going to be fine. Another case that is a bit complicated, for example, this is how Symfony works. So again, you have tagged version one, so first stable version, and you're going to create like a new releases, so 1.1, 1.2, and for every release you have to create something called a release branch, so that you will be able to get back in time and provide the bug fix. So for example, you have a case, you have a new issue, and the user comes to you and it says, okay, in version 1.3, for example, we have a bug. Now, what you need to do, you need to go and analyze your code and check if that bug appears somewhere earlier. In my case, for example, I have a bug that is started appearing in version 1.1. So you have to go onto the version 1.1, fix that, provide the bug fix there, so you're going back in 1 to 1.1, and then what you're going to do, you are merging the changes upwards. So you are finding the least supported versions out there, and you are providing fix upwards, merging upwards. The same things go with features. If you provide new features in like 1.1 version, you have to always merge upwards back into development branch. And if you take a look at Symfony, for example, the same thing are they doing. So you have a lot of release branches, for example, so that they're able to go back and support like version 4.4. And another screenshot of Symfony. So basically you have the same thing what I said. They're merging 5.0 into 5.1. 5.1 gets merged into 5.2, and 5.2 is merged back into development branch. So that's how they are maintaining their releases. But usually it works for Symfony, but for you, you'll probably end up something like this. You will try to follow Semver, but yeah, you'll have some screw-ups, but it's perfectly fine. The next thing I wanted to cover is a changelog. Changelog is a file that contains a curated, chronologically ordered list of notable changes for every version of your project. So the changelog is not a list of commits. I've seen that so many times. When you have like a big pile of commits, okay, that's my changelog. It's not. And you have to go all over all those commits to find out what happened. That's pretty much very daunting. So there is a project called Keep a Changelog that defines the standard for changelog. They have defined the format that is very readable, that when you open that changelog, you can see, okay, this was added, this was removed, this was fixed. And you can easily spot those things. The next thing is something called README.md, which is the main Markdown file that is being read when you go with your browser to the repository. And usually what I tend to do, I try to keep it simple. I just put some small introduction text with a brief overview. I put the links to documentation, licensing, whatever, changelog, just very simple. And what I tend to do, I tend to put those badges, which reflect the state of your, for example, state of Travis, state of Scrutinizer, latest version, whatever, and a logo for the project. But that is an exception in this case because usually you need to have a good designer that will help you with this, which usually is not the case for me. And those badges look good, don't they? Right? So there are a lot of websites that can provide you with those badges, and somehow I just kept returning back to shields.io. It's a website where you can just paste the URL to your GitHub page, and it will generate like a ton of links for every single service that you can think of. Just copy the service that you want, the URL to the service you want, and paste it into your readme.md file, which of course will not work if you like copy the URL for Travis and you are not using Travis. It doesn't work, obviously. And all those tools, services, and all those things that we went through can be a bit overwhelming. So that's why the guys from the PHP of Extraordinary League and from the PHP DS, they have created something called Skeleton. They have skeletons that are providing the templates for the configurations for the PHP stand, Psalm, Travis, Scrutinizer, whatever you can think of. Even the README files. They have provided every single thing for you. You just need to run the initialization script, and they basically update project name, README for you. So it's a very nice thing to use. And we are almost there. And to be able to install the library, what we need to do, we need to add our project to the something called Packagist. And Packagist is a resource where Composer checks for the new packages, for the new versions, packages, whatever. So basically, you just need to log into the Packagist, put a link to your GitHub page, enable the sync, and it will automatically update every single time you create a new tag, basically every time when you create a new release. So in a matter of 2 minutes, you will be able to do something like a composer require your package, and you'll be able to install it. And basically, we are done. And just a small summary for the end. It's a bit overwhelming to do every single thing in one step. So I suggest go step by step, experiment with those tools, try to find the ones which suits you the most, find even some new ones. And the biggest issue won't be those tools. The biggest issue for you will probably be the lack of time, because we all have lives, right? We have jobs. And you don't want to devote the whole free time that you have babysitting an open source project. That's hilarious. So try to devote like hour or two weekly to that project. Go to the GitHub page, skim through the list of issues, check for comments, put your comment, try to give the sign to other people that you are into maintaining that thing, so that they can be even more, so that they can know that something is happening here. Also, appreciate the feedback. Try to ask other developers, okay, is this good for you? What would you like to change? What would you like to see in my project? Try to update, try to cover that in the future releases. Try to remove the parts that are not being used, because you don't want to maintain the code that nobody uses. And basically, the whole experience of maintaining the open source project is going to be pretty much very rewarding, and you will learn a lot. And today we saw a presentation by Antonio about senior developers. I'm sure that this is one of the ways to get you into the senior level, because you would build something by yourself, you would maintain something for yourself, and you would gain a street credibility. So I definitely suggest that you try to create your own open source package. And the most important thing for the end, there will be people who will be putting like a mean comments. Just ignore them, because they are not worth of your time. Thank you. Thank you very much.
Thank you, Mario. Now let's check. Oh, we already have a question. Now let me see whether we have the mic. Yeah, we have it. Just a second. Take your time.
Hello. Thank you very much for pointing out that documentation is important. I have a two-part question. So when you maintain your own repository, there is a time when people come and demand new features. So how do you handle like requests for new features that you haven't planned? And the other part is some just come and create pull requests. And it might be a good idea to have that in your repo, but then you end up maintaining it. So how you handle those situations?
Exactly, that's a good point, because all those skeletons that I showed, they have the guides how to create pull requests, so it's definitely great resource to check it out. Personally, this was the repository that I built for my company, so I even got paid for doing the open source, which was amazing. And basically, the new features was business requirements. Some of our partners, they request new features for that, and we build that into basically through the open source. There were like a few requirements that went through the GitHub, but it was like very small amount of them. And usually, most of the contributors on this project were my colleagues from my company. So we were kind of team, and you can basically help every single guy in your team how to do a pull request. We have like 2 or 3 guys that are from Germany or somewhere that did pull requests. So it was not like a big project. So it has like something like 30,000 downloads, which if you think it's specialized in easy platform community, so it's is a lot, but it's not generally available package. So I'm proud of it, and I hope that this answers to your question.
Yes, thank you.
Another one? Oh, back row. Last row, actually.
Hi, thank you for your talk. I have a question. Are there any automated tools which help you make sure that you're following Semver?
Yeah, there was one tool in the form of my colleague, which was like a top senior guy who actually understands everything, and basically he helped me because he was like a true mentor, and I would like to thank him for that, because he had like for that time I was not senior, so I didn't have like a big overview of everything, and when I wanted to create something new, I always talked to him. Okay, what do you think about this and this and this? And he always told me, okay, with this you're going to break something in the release, blah blah blah. So I would say you have to learn that by doing, by experience. You just there aren't tools that can help you with that. It's something that you will start to noticing as you are getting older. By older, I mean experienced. Hopefully that answers your question. It's very hard, hard to explain that, but now when I'm experienced, I can see, okay, when someone says, okay, I'm going to do that and that, I can see, okay, that's fine, but you'll break this, this, and this. I would say it's just experience, nothing else. And this is a great way to achieve that experience when doing open source, of course.
No. That's it. Thank you, Mario. Let's
Thank
hear it
you.
from Mario.